Right, so, sorry, I'm going to put everyone to sleep now. So it's really just a short 30-minute grounding in using LEDs and things you need to be aware of. And there's not going to be any turning. But it's really just to tell you the basics and maybe throw out some ideas and things you can use and if you want to incorporate them. So I've just got a slideshow here. I'm sorry it's a bit hobshy-gobbling. I was originally planning to project it on the second telly, but we don't have that. So basically, I'm just going to go through some basics because there's some things about electrical circuits that you all need to know, and you probably already do know, but it's just so that the terms I'm talking about that you understand already. So basically, that would be a simple circuit where, say, you have a battery driving power and it's driving current around, and it's a circuit because it has to be complete, it has to go from one terminal of the battery and back to the other. And you can think of it as being analogous to say, water flow through pipes. So if you have a trough of water up high and you've got pipe work running down to a pond below, then the higher you have that, there's going to be more water pressure and it's going to drive the water faster. So it's exactly the same with electricity. So basically, the height of your trough would be analogous to the voltage. So the higher your trough, the bigger the voltage. And when you're talking about voltages, basically what my science teachers back 40 odd years ago when I was at school used to tell us off if we call it voltage. It's supposed to be potential difference, and it's basically the difference in potential energy between two different points. So because nature abhors anything being unequal, it will drive a current to get the thing equalised. So basically, you then have current being driven by that voltage, that can do work like lighting up a lamp. Sorry.
I think the black is meaning that this is overexposed. So would that make any difference?
No.
Is that any better?
No.
Is that no good? No?
No, it doesn't change.
You just can't see it.
I tell you what. If I hold this up like that,
Yeah.
is that any better?
Yeah.
Right. So,
You can put it on the leaves.
is that all right with the screen here? And people on that one?
It's on that camera here.
That one? How's that? Okay?
Tell me we left off.
Okay, sorry, this isn't, I'm going to dispense with this in a sec, it's really just to, so here you've got a simple circuit with a battery driving current through a normal electric lamp. And here you've got a brake, which means that no current is flowing, it can't flow across the brake. So that could be a brake in a wire, it could be a switch that is switched off. So that's a way of controlling whether the circuit is running or not. So this picture sort of describes the difference between voltage, current, and resistance. So you've got volts, which is pushing the current through the wire. But then you have the concept of resistance, which is like squeezing the wire and stopping the flow of current. So it's just important to understand those concepts, and I've probably explained them really, really badly, but you've basically got a relationship between these, which is Ohm's law, basically, where V equals I times R. I is for current. Historically, that's because Ampere, who discovered current in French, called it oh God, I can't remember. Again with I. In French, it's just taken from that. So basically, these equations, this is sort of the most basic equation around electrics. V equals I times R. Equally, R equals V divided by I, or I equals V divided by R. And that's in those units, the volts, the amp, and the ohm. Okay, does that make sense so far?
No.
I'll just give up now. This is the other key thing that you need to be aware of, is the difference between series and parallel circuits. So series is where, say, you have a battery or a power source and you're running things one after the other, so it's daisy chained around one to the other. Parallel is where basically you have it branching off and going to each one separately. And the differences with these is that with a series circuit, the voltage divides. So the voltage drops for each thing that's going around the circuit. So if you're doing this, I don't know if anyone ever played around with the sort of electronic sort of kids sets and things where you could discover this and that. And the old sort of classic incandescent light bulbs and that, basically the bulbs would be less bright here and they'd be full brightness here. So in parallel circuits, the current divides. So basically in this case, your lamps would be brighter, but your battery would drain faster. Okay? So what is an LED? An LED is a special type of diode. A diode is a device that only lets current flow in one direction. So it can only flow one way, not the other. And it has light-emitting properties when the current is flowing through it, or enough current is flowing through it. So basically, typical LEDs, I'll pass one round. So I'm trying to find one here, please, on the fence. Sorry, so can you see that? See, one pin is slightly longer than the other, and that's telling you which side is positive and which side is negative. So basically going back to this again, that's the electronic symbols for a diode, sorry. There we go. So it will only let current flow in that direction. And the pins, the positive pin is called an anode, the negative pin is called a cathode. And you don't really need to sort of get into all this stuff, that's just all the parts internally that cause an LED to generate power. But what you will find is that different LEDs, the colour of it will change the characteristics of how much current and voltage can flow through it, because basically the properties of the materials that they're using for those colours to generate them in the LED. So this now is a simple LED circuit. So as simple as one you can get, where you've got a battery, you've got the LED, and it's driving around. But here you have something else, which is a resistor. That's very important. So like basically, you should always have a resistor in any circuit you do with an LED, because otherwise the LED will draw too much current and it will blow. What will tend to happen is if you overcurrent, it will light up really bright for a second and then go, and that's it, bang jazz. So basically, that's just an explanation of why LEDs are so sensitive, what the resistor's job is. So, basically, when you're trying to work out what resistor you should size for a particular LED, this formula gives you. I'm not going to go through that because you don't need it. This is a data sheet for LED. Anytime you sort of buy LEDs, if you buy LEDs off of the likes of radionics, they'll have data sheets like this. Pass that round, and that tells you all the characteristics of LEDs. The things that you're interested in are, the forward voltage and the forward current. So basically, the forward voltage is the minimum amount of voltage that the LED needs to actually generate light. And the forward current is the current that it will typically drive. So this LED has a forward voltage typically 2 volts. It has a forward current of 30 milliamps, so that's thousandths of an amp. And it's important to remember that it's milliamps and not amps. And peak forward current of 160, is that? Yeah, 160 milliamps. So basically, if for any length of time it's hitting 160 or above, then it's likely to blow. So that's why you need to size your resistor. So this, fortunately, there's loads of handy calculators in which you can just get on the internet to do this. So this is one for DigiKey, so digikey.ie. If you go into their website and just search, they've got loads of calculators for all different sorts of things. So this one, you can just put in the supply voltage. So say I'm running this off of a 9-volt battery. I know from the data sheet that the forward current is 2 volts. The forward voltage is 2 volts, and the forward current is 30 milliamps. So then in the black here, this is telling me that I need a resistor that's at least 233 ohms and can handle a power of 0.21 of a watt. So basically, when you get resistors, go into this. These are resistors. These are, actually this is 1 mega ohm, so you wouldn't get much light out of an LED from this at all, but just pass that around for you to see what they're like. I won't go into it now. The colour markings on the resistor tell you what resistance it actually is. There's things online for helping you read read that. What you can also do is if you have a multimeter, you can just put it onto the resistance setting.
Ricky,
Yep.
said that you've just done the voltage and the average of
Yeah.
one end and the resistance was LED.
Yeah.
If you had loads of LEDs, would that be the same voltage and average? The resistance?
Depends whether they're wired in series or in parallel. The safest thing to do is to wire them in parallel, and I'll show you now. You should always have one resistor per LED. You should never try and run multiple LEDs off of one resistor. And the reason for that is that the characteristics of the circuit might change if, say, one of the LED blows. So it will change the voltage that's going through the others and the current. So the safest thing is to basically, if you're running multiple, here you've got a thing here where it's showing sort of multiple ones. You can run that with a single resistor, but you have to be really controlled in what that do. There's a lot of issues with that. If you run them in series, say if one of those LEDs blows, it takes all of them out because it's broken the circuit. Where if you do it this way and you wire it parallel, if this one goes, they will still work. So it's the same principle of your Christmas tree. You know the fairy lights on the Christmas tree, and you take it out and you switch it on and nothing happens, and then you have to go through one by one changing all the bulbs. And that's because they're wired in series, and breakage in any bulb takes out the whole circuit. So I'm going to stop with that now. That's the sort of grounding basis of it. So just to show some practical stuff. When it comes to using LEDs in your turner, you've got a few options. You could just buy something that's pre-wired. The problem with this is that these tend to be quite chunky, and it's difficult. If you've got something that's small, they're quite difficult to fit inside. And you might not want that many LEDs. So generally, if you can wire your own circuits, you can get these things pretty small. Something that's really useful when you want to test circuits out and prototype with them is to get a breadboard, which is and that is basically, it's just an easy way for you to connect wires and connect things and just test out a circuit without having to worry about soldering. And that's so, if I just quickly wire up one of these. So I've got a couple of batteries here. I've got a 9-volt battery on this thing. So you can see there's a positive, a negative, red and blue. So I've got that wired in, and that will run to all of those ports there, and then these ones are going across. So those 5 are connected, but those 5 are connected, but they're not connected to each other, either side. So I've got a resistor in here already, and if I connect the long leg of this into the same as the resistor and the short leg there. And then that. So I'm now going to complete the circuit by connecting this to the negative, and hopefully, if that's on, there we go, the LED is lit up. So if I wanted to connect, sorry, it's gone.
That's what happens when batteries go into series instead of hard.
So it's me draining the batteries, sorry. Sorry, I'll talk a bit louder. So that's a simple circuit here. I'll just take that out for a minute. That's all you've got here is wire running to the battery, a resistor, then the LED, and then back to the battery again. Okay, so that's the simplest circuit you can do, and the chapter challenge that we had last month here, the ship that was hanging from the roof of that just had an LED in the back of it. It had thanks. So the LED that was in that was just basically this circuit. So one of these LEDs, which are quite good because they're screw hole. I'll pass it around. They've got a threaded bolt and a nut on it, so if you have a hole drilled, you can just drill it in and surface mount it. Sorry.
Can you cut that power down to get it into?
Can I what? Sorry.
Can you cut that power down just to get as many parts as you need?
Looks
very big.
No, you'd be better. You can buy smaller boards though. But this is really just for prototyping. This is just for me working out what I want in a circuit before I go with the soldering iron and start wiring things together. So basically, if I was taking this circuit now, and I'll just show you about soldering. Has anyone here done any soldering? What, sorry? This?
That white thing on the ground.
Board.
Oh, the board?
The wire's hanging out.
No, the board is just for you to connect things to. So you can connect different things and try out your circuit and make sure that you have the right LED and the right resistor and everything before you start wiring it up properly. So this is sort of, if you want to do any of this stuff, you can sort of do wires with sort of little connectors like this if you don't want to go near the soldering iron and, you know, use those things. But it's going to take up space again. It's a lot neater if you can solder. So you get soldering irons for next to nothing. I think that might cost me 10 and little. It's a little battery powered one. So something you do need if you're soldering is either 3 hands or some sort of clamp, because you have to, you need to hold the wire, but you also need to hold the soldering iron and the solder. So I'm just going to wire. I'm just going to wire one of these resistors. The other thing, the LED, it matters which way you wire it. The resistor, it doesn't. It can go either way. Doesn't matter. So, if you're soldering something, this is soldering paste or flux, which just cleans up the connection. And the same if I want to solder that to the LED.
That looks good, that. You flux both of them, Richard, just...
I would, yeah. So I'm just trying to hold this. Still not doing a very good job of this. So the other way, you just get the flux on the screwdriver and just rub it on. So this thing, you just need to hold that button down for a minute. You can get other soldering stations where you plug it into the mains and it's sort of permanently there. It's very important to keep this tip clean. I don't know if you can see it's a little bit black in there, so that's what the wide brush is for. Just to keep it clean. And then what I'm doing is I'm applying heat to the wire of the thing here, and then so the solder, I don't know if you saw then, just as it sort of got hot enough, the solder started to melt and it ran. So that's a really botched, rushed job, but there you can see now I've soldered that to the resistor, so that's how you can sort of wire these things together and make complete circuits. So that's sort of one option of what you can, things you can do if you're just doing simple stuff and you want a small battery holder like this that you can sort of control. You can do more interesting things. For example, say if you want to control the switching of your LED, but I'm not sure if that's on that way. So. So that's now wired as it was before, but I don't know if you can see there, it's going through this thing, which is basically one of these. Which is called a reed switch. So, basically, a reed switch, you might have these at home. If you've got a burglar alarm in your house at home, you'll have these. The sensors that you have on the door and windows are these things. And what happens is when you bring a magnet close to it, it closes. So, when you're in the burglar alarm at home, there's a magnet on the door that's close to the sensor and it keeps the switch closed, and then when you open the door, the magnet moves away and it opens and it's detecting that. So you can use exactly the same thing to bring this in. When the magnet's close, you've got a switch that works.
I can't so you see what you're up there. So glasses ain't what you up better.
Okay? So like, you can see there, as I bring the magnet close to that,
On the telly, you can't see the light.
you can't see the...
We can't see the
How about now?
Yeah.
Okay, so basically you could do something like that where you've got, you've got a circuit but you only want to switch it on so something moves in your, whatever you have turned. You have a magnet set inside, and when you twist it, it brings the magnet round and switches it on. So that's just one idea. You can sort of take this to a totally new level. So there's absolutely tons of videos, stuff on YouTube on this stuff if you want to get into it. And, but that's the sort of most simple circuit you can do. You can take it to the level of getting things like, this is an Arduino board, which is this thing in here, which is like a little microprocessor that I can control LEDs with. Basically, these are what are called RGB LEDs, where it's got the three colours in one. So by using different combinations of those colours, the intensity, and what it does for the intensity, what tends to happen with an LED, if I show you can change, you can make an LED slightly dimmer by changing the resistance, by increasing the resistance, but it tends to be far less pronounced, and then you'll just get to a point where there's too much resistance and the light will just go off. So what these actually do to change the intensity of the light is switch on and off really quickly. So basically it's continually turning the light on and off, and the more it's on, the brighter it appears to you to be. So that's how they're using those different combinations between the three LEDs to get the different colours. So that's all programmable. It's actually, if you're into that thing sort of thing, it's really interesting and it's really easy. And it's absolutely incredible now. With AI, you can just say, go and write me a program. I want to turn this LED. I've got an Arduino. I want a program that will turn this light on, connected to these pins on here, and it will go off, write the code for you in seconds, and you can just cut and paste that in and load it onto this, do it. So you don't need to be a programming expert to do any of this stuff. But this was basically the stuff that we used in the bulk of the chapter challenge piece, the source of the stuff. So So I think I'm past my time, but the one other thing I wanted to show you was this, which you don't actually need to have the LED connected to the electricity or to the circuit at all. So does anyone here charge their phone wirelessly? Yeah. So this is exactly the same principle that your wireless phone charger has a coil in it that creates a magnetic induction, and then there's a coil inside your phone, and when the two are placed close together, the current in one induces the current in the other, and that's how your phone charges. So this is a little kit I picked up off of Amazon. Was under €20. So it comes with this coil and a little USB connector. And it also comes with these little LEDs. What you see is this is typical. I tested this last night. It's that LED. So here you go. So that gives you a way of having LEDs in very small things that don't actually have to be connected to the electricity or the power, the source of power, the battery or whatever. So you could turn something very small and just insert one of them into it. And if you have some sort of base where you have this incorporated, you can just use that.
And would the wood not interfere? Would the wood, if you put that in the base of the wood and you have the line, would the wood not interfere with the...
No. It should go through, unless the wood, I don't even think if the wood was very wet. Well, that's good.
Yeah.
So it's, you can see here as I bring it closer, the further it has to be,
Yeah.
you know, the intensity goes up as it gets closer, so it has to be within the field.
Relatively close, yeah.
But it's a nice little kit if you want to play with it. Like I say, they're on Amazon. They're about 18. I think I paid about €18 for it.
What's it called, Richard? What's the kit called?
I'll have to tell you now. It's it'll have something like wireless LED in the name, but I can find the link and let you know. In fact,
Which is that link connects to anything? That involved ring connects to power.
yeah, the coil here is, so you can see the coil there is connected to a USB cable. You can, you can sort of you can just make these yourself, but you need to have, you can't just connect this coil to a battery because for the induction to work it has to be constantly switching, so you'd have to have other things in your circuit to do it. But well, basically, here you can see there now as I bring it. I wish I'd thought of this before the chapter challenge because there's so many things I thought of in life. I only got this week, so that's why I haven't actually made anything with it yet. But there's so many ideas I've had of things that we could have done with the chapter challenge for this. But,
Rich, put the coil under the table. That answers the question about.
There you go.
Yeah.
So yeah, I mean, it had no problem working through the base of the bowl, or, platform or anything. So it's just a really little idea if you want to do something unusual with them. So,
Yeah. No, absolutely. Yeah.
So yeah, I'm sorry, I was just going to look up the thing on Amazon. I got it off of Amazon UK as well, but I'd say you could probably get it through the Ireland one. Okay. So it was this thing, so it's called a wireless LED lights, long distance wireless coil.
Wireless LED light and then what?
Wireless,
We can't see on the
yeah.
somehow it doesn't work.
That coming?
No, it's only a white screen, that's all.
Oh, okay. I can get it. I can ask John to put it up on the website.
Yeah. Anyway, we can.
So, but yeah, if you search for wireless LED,
Yeah.
you'll find it fairly early on in the search. So it's.
Circuits.
Does anyone have any questions off the back of that? I'm sorry it's all a bit disjointed, but it's sort of hard to do in half an hour.
Yeah.
I sort of wanted to make sure that you had enough of a grounding when I'm talking about voltage and resistors and things that you understand why.
If we're going to incorporate this into a bomb, which explosive we prefer?
I can't give all my secrets away. But there's no end to stuff you can do with this stuff once you get into it. But start off with something like this, where you've just got a simple circuit, an LED and a resistor, play around with it. Like the breadboards, like a lot of this stuff's for nothing. The more of it you buy, it obviously starts racking up the cost. But like those are about €5 from Radionics in Rialto. You can buy 100 resistors for a couple of euro, and wire and stuff. So it's certainly worth having one of these to sort of try stuff out before you start, soldering it together and work out exactly what you want. on there. But I hope that gives you an idea anyway and wasn't too boring.
Yeah, thank you.
So.
Thanks for watching, and don't forget to like and subscribe. See you in the next one. Bye.